I hope everyone is having an enjoyable weekend. This is by request from a couple of my students that were in tutoring the other day. They want to see this on a video. This is what I did in tutoring, I think on like Wednesday or something. We're going to go over the trig basics, but I'm going to go a little bit in depth on the very last example, so stay tuned toward the end, please. And that may help you understand more about how trig works. But first, the main reason trig works is because the triangles are all similar. When we're dealing with right triangles with the exact same angles, say we got one here, it's a small triangle, but 3357, it's similar to something that I just expanded out or did a scale factor to. So when I do A over B, it's going to come out to some decimal answer like 0.722 whatever. Well, this similar triangle with the exact same angles, when I do X over Z, is going to come up with the exact same ratio. So if we can figure out the ratios and we're given one of these sides, we can figure out the other side using trig. Now in the old days we had to use a lot of tables, but nowadays we're just using these calculators to knock out these missing parts. So let's get to our first example. The first thing you need to know is how to find the adjacent, the hypotenuse, and the opposite side. Okay? So what we have is, let's just take a look at angle A. We never really look at the 90-degree angle. We're going to explore more of that in later courses. But we're just going to look at the two acute angles, angle A and angle B. When we talk about angle A, we're talking about, okay, we're taking a relationship. See this side right here and this one here? The one opposite the 90 is always the hypotenuse. The one touching it is always adjacent. Over here, this side here is our opposite. Now looking at angle B, right here, here is going to be my opposite, and here will be my adjacent. The hypotenuse is always the hypotenuse. The only two sides that touch an angle when we're talking about a specific angle is the adjacent and the hypotenuse. The opposite never touches the angle, so the opposite of B is right here. The opposite of A is over here. The adjacent of A is this angle here. And the adjacent of B is this one here. You need to know these things before you can progress. So study this, and then you can go to the next level. And that is the trig ratios. You get the formula charts on your EOC and stuff, so this is something you don't have to have memorized, but I caution you, if you do your practice, you're going to have it memorized. Your brain accepts it better when it's memorized. And if you have to look at the formulas, be honest with yourself, you probably haven't practiced enough. So let's go ahead into specific examples. First, we're going to look at the sine of C. So the first thing I do is look at the angle, and I go right here. My eyeball goes to angle C. Then I look at the definition. We're looking at the sine, which means opposite over adjacent. So on one of your first homework assignments, opposite over hypotenuse, I asked you to write every single one down. So opposite over hypotenuse. So it's equal to 28 over 35. And we simplify that fraction. 7 goes into both of them 4/5 time. So we go to cosine. Cosine is adjacent over hypotenuse. And my eye goes right here to A. And I look at my adjacent side, which is here, because it touches A. And my hypotenuse is opposite my 90, so it's 30 over 34. Right here. Alright, I'll just cut those in half. That would be 15/17. Now we go to the tan. And I write my definition down. That is opposite over adjacent. And the more I do this, the easier it's going to get. Then I look at my angle here, angle X, and I go opposite, which is 32, and adjacent, which is 24. So I have 32 over 24. Okay, 8 goes into that, so we're looking at 4/3. All right, so moving on. We are ready for level 3, finding a side. Now when we're finding a side, we're going to use the trig ratios. Our first thing that we do is go straight to the angle, right here. Our eyeball looks at that. Then we determine what sides we're given. That determines our trig ratio. So I'm looking at 59, and I know by definition that over here is my opposite, and opposite my 90 degree is my hypotenuse. Remember, adjacent is this side. The hypotenuse is always the hypotenuse. So we have opposite over hypotenuse. That is sine. I write my angle, 59, is equal to x over 126. Now I have an algebra problem. I have 126 in the denominator. To get rid of the denominator, I multiply by 126 on both sides. So I'm going to multiply by 126 on both sides. That cancels that out. 126 over here. Don't put the 126 over here. That can confuse calculators big time, even if you put it in parentheses. All right, so 126 sine 59, and we just go straight to our calculator. We don't have trig tables anymore. Those are relics of the past. And I could, with the CASA, you don't have to put in the multiplication symbol, but you can knock it out, and my angle is 108. And very often we round angles, on my side, to the nearest hundredths or so, but it looks like 108 will be the rounded answer. Okay, so let's go look at this one. We got our angle 14, that's where our eyeball goes, and we have an adjacent and the hypotenuse. The hypotenuse is always opposite my 90 degrees. So adjacent over hypotenuse, that is cosine. So we have cosine of 14, my angle, is equal to adjacent over hypotenuse. Now when we do this, we're still going to use our algebra. Now I've shown you, for my geometry students, you've already had algebra, but what we're going to do is we're just going to solve it like we normally would. I'm going to show you the long way to do it. This cancels out, so that's gone. And then we have x cosine 14 is equal to 79. That's a 4. Promise, promise. And then we're going to divide by cosine 14. Remember, this is just a number. It's just some kind of ratio. If I put cosine 14 here, I'm going to get some weird decimal. So I have x is equal to 79 over cosine 14. All right. And I put that in the calculator. Now look what we did. Here's my original in purple, even though it's badly written. This cosine went and changed places with the x. Now that's just a quick algebra trick. If you're not good at algebra, don't do the trick. All right, simple as that. You need to go ahead and practice these steps that I just showed you. That way it'll get into your brain on what's going on. No trick if you're not good at algebra. Okay, if you're very good at algebra, just go right to it. And we just put this in the calculator. So let's go ahead. I'm going to put 79 divided by cosine 14. Knock it out. You're done. That angle, that side right here is 81.42. And we are solving this triangle. Moving on. If you could do that, you're ready for the next one, finding the angle. So what we need to do is we're going to look again at our angle. That's where our eyeball goes first. Then we define our trig function. It looks like I have opposite and adjacent. That means tan. I'm going to write out my definition. Tan of my angle, just so happens to be x, it could have been a number on another problem, opposite, which happens to be 18, over adjacent, which means 59. And I'm going to solve this. Well, there's no algebra involved in this one. This one goes straight to definition. We're going to have to use the inverse. When we're doing angle, think inverse. So I'm going to have my inverse of my side, 18 over 59, is going to equal to my angle. Can't do much more other than put it in the calculator. So over here on my calculator, I have my shift key because that's going to activate these guys right up top here in that funny little yellow-orange color. There's my tan. I'll go to my fraction symbol, put 18 over 49, tab down, 59, enter, and there's my angle. Looks like 16.96. We'll call it 17 degrees rounded. So my angle is about 17 degrees. Let's do the same thing over here. So we have our angle. My eyeball goes to that first. I have adjacent and my hypotenuse opposite my 90 degrees. That means I'm dealing with cosine. I'm going to put in cosine of my angle is equal to my adjacent over my hypotenuse. And straight away, definition, inverse time. And I'm going to put 58 over 75. If you do this, if you show me your work instead of going straight to the calculator, you're going to get partial because sometimes people put in a wrong number in the calculator to do something slightly wrong. So let's go hit shift cosine. See my negative sign right here. That means we're in inverse mode. And I'm going to do 58 over 75. And my angle is 39.35-ish. Okay, so we're just going to call it about 39 degrees if we round to the nearest degree. Okay. Now we're ready for the last stage, and that means elevation and depression. We talked a lot about this in class, and the hugest thing is to understand that both of these will have horizontal lines involved. It's line of sight. This guy's looking straight ahead. He's either going to look up or he's going to look down. If he looks down, that's angle of depression. This guy right here is looking straight ahead. If he looks up, that's angle of elevation. It's all from the perspective of where the angle meets. See the vertex right here? This is going to be an angle of elevation because you have to have the horizontal line. Here's where the angle meets. Here's my horizontal line. This is going down. So let's take a look at an example. Here we have an airplane at 3,500 feet, and the angle of elevation from the airport to the plane is 29 degrees. When I start doing these, I just simply start drawing the picture as I read it. So I'm going to go ahead and say, okay, this guy is 3,500 feet. Okay, and I want to find, I'm going to draw a dotted horizontal line to the airport. Now the angle that it makes from the airport, from the ground to the plane, is 29 degrees. So here's my angle of elevation right here, 29. And it wants me to find the distance between the plane and the airport, the horizontal distance. That means this. I'm going to call that x. So what I got now is a trig ratio. I got to figure out which one. I look at my angle like always. I have an opposite and adjacent. That means tangent. So I have tan of my angle, happens to be 29, is equal to opposite 3,500 over my adjacent. And skipping some of the algebra, I'm just going to go straight to it, and I'm going to have my angle is equal to 3,500 over tan 29. And I know I'm going to get a number bigger than 3,500, and that's why I want you to save your wait till the end. I'm going to explain why I know this is going to be bigger than 3,500. So let's go ahead and knock this in the calculator. 3,500 divided by, where's my tan button? Tan 29. Boom. And I get 6,314 feet. All right? So 6314. Pretty far away. All right, so this is 6314. All right, about that. And closing fast. Let's go to another problem. And you've seen this one like 3 or 4 times now. This is a very common trig problem. You got a 15-meter pole leaning against the wall. Let me draw the wall first. Here's the wall. And here's the pole leaning against it. And it is 15 meters. And it is 10 meters from the wall. So this is 10. My hypotenuse, of course, is going to be the longest side, so this is going to be a little bit smaller than 15 if I were to find the wall height where it touches, but it's asking for where the angle is. So I just look at my angle. I have adjacent, and I have opposite. So that means cosine. Cosine of my angle is equal to adjacent over opposite. And I go back to one of my previous skills, my level 4 skill where I'm finding the angle. That directly translates into the definition of inverse, and I'm going to take 10 over 15 and find my angle. So I go over to my calculator. Can't do this without the calculator. We don't have those tables. And oops, I want to do this. Shift, cosine 1, hit my fraction button, and knock her out. And we're looking at about a 48-degree angle. So review these problems and do them on paper. Again, watching is not learning. You got to practice them. Now let's go look at this problem. I'm going to show you something, and it's going to be a lot of calculator work, so I'm going to clear this calculator out. Now take a look at this. This is the earlier problem on the angle of elevation. I've already got most of it set up for you. And what we have, and this is a very important example if you want to start to understand trig a little bit better. That's why I asked you to save this to the end. Now what we have is a plane coming in to the airport at 29 degrees angle of elevation from the airfield or the tower, wherever you want to look at it, to the airplane, and it's 3,500 feet above. Now this 29 degrees right here, see it? And this is where trig gets interesting, and we calculated to about 6,300 feet from the distance from the airport. Now watch what happens when the plane gets closer. It's flying. It's going to do a flyby. It's not going to drop in altitude. So we're going to change this angle, and the angle gets bigger. So let's say this is 35 degrees now. So I'm just going to take out this 1029 and put in 35. Look here what I did in the calculator. Oops, we got to get rid of this. So originally we had 3,500 divided by 1029, and it came up to this. So now let's say they're at 35 degrees. Watch this. 3,500 divided by 1035. The distance got shorter. He's now closer to the runway. The angle is increasing. Now what's your prediction if this tangent gets to 45, a 45 degree angle? Now that means an isosceles right triangle, 45, 45, 90. So let's get him a little bit closer. And here comes the plane. Now we're at 45 degrees. Watch this. 3,500 divided by the tangent of 45. Boom. He's exactly the same distance. So this right here, 3,500, is also 3,500 here. We have an isosceles right at 45 degrees. Now what if he gets even closer? Let's say he's at 50 degrees now. He's gotten really close to the airport. So we're going to do 3,500 divided by 1050. The distance got shorter. He's higher up than he is closer. And what do you think is going to happen the closer he gets to 90 degrees, which means he's straight up and down from the airport. So let's go ahead and zoom in at 80 degrees. He's really up, almost close to the airport now. He's really up there. So we have 3,500 divided by 1080. He's 617 feet away. He's about to buzz us. Let's get him right up to almost 90 degrees. So here we go. 3,500, and he's almost at 90. So we're going to call this 89. Oops, I need to delete that. Put 1089. And he's 61 feet away. And you're probably wondering, what if I put 1090 in there? Watch this. 3,500 divided by 1090 gives me an error. You know why? We can't divide by 0. So that means he's straight up and down, 0 feet away. Knock it out. So this is actually a pretty good illustration of what trig does for us. Okay, I'm going to have this uploaded. I have to edit a little pause out. And then I will do another video, probably on rectangles. See ya.